This is the worst 2x4 I could find at Home Depot. It cost me $1.06. Most people would never buy a board like this. I bought it because I want to turn it into a snare drum. In this video, I'll show you what happens when you buy rejected lumber at a discount. I'll build a bunch of really cool jigs, and I'll attempt something most drum builders would probably tell me not to do. Build an instrument from construction lumber. The only question is, will it warp? Will it sound good? Or am I about to find out exactly why nobody builds drums this way? What could possibly go wrong? The game plan. This is my Mapex Black Panther snare. It's the best snare I've ever played, and it sounds incredible. Fire, as the cool kids say. Do they still say that? Anyway, my son is starting band this year, and I want to make him a custom snare to start learning on. My requirements are simple. 1. It needs to be 14 inches in diameter and 6.5 inches deep. B. Instead of using bent wood laminations like most drum manufacturers do, let's build the shell using staves and make it thick. Roman numeral 3. Snares usually have a logo badge, so naturally, I want to make my own, design a logo, and name it after my boy. And since this is YouTube, instead of making it out of walnut, which is what I want to do, I'm going to challenge myself and see if I can pull this off using 2x4s we all hate building with. Usually when I buy 2x4s from Home Depot, I spend my time digging through all the hockey sticks looking for the straightest boards I can find, which 60% of the time end up as hockey sticks in my workshop every time. But on this trip, something weird happened. Not only was I able to find a bunch of really straight 2x4s, the moisture content on them was surprisingly low, like 7% low, which if you didn't know, that's fine furniture lumber territory. Now usually these things are closer to 20% moisture content, which is one reason why they don't stay straight for very long. Now while I was standing there with a camera in one hand and a moisture meter in the other, a Home Depot employee named Cowboy Mike walked over and asked me what I was doing. I channeled my inner Texan and said, "Hey partner, I'm looking for some straight 2x4s. We both laughed at this absurd banana-shaped board sitting in a pile, and then he said to me, "If you want it, I'll give it to you for 70% off. Now, I had absolutely no intention of buying the worst board at Home Depot for $1.06, but with country music over the loudspeakers and Cowboy Mike breathing down my neck, what exactly am I supposed to do in that situation? I folded. So I left Home Depot with an idea. I'd mill up 3 different species of framing lumber, whitewood, Douglas fir, and southern yellow pine, and as a bonus, I'd throw in the crooked southern yellow pine that Cowboy Mike gave me for $1. I'm pretty sure this is not going to work and it's going to be a waste of time, but for $1.06, I think we should try it out. Yeehaw. Let's play a little game. Out of all the 2x4s I bought, which one do you think will be the best looking option? I'll go first. I'm voting for Douglas fir. Now while you think about that, let me explain what I'm doing. Instead of bending thin layers of wood into a cylinder like most drum manufacturers do, I wanted to build this shell using staves. Think of it like building a barrel, just with fewer pirates and liquor. But the challenge is, each piece has a very specific angle on the sides, and they have to be a very specific length, and they have to be a very specific thickness, and when you put enough of them together, they make a circle if you did everything right. And so to figure out the exact width, thickness, and angle of each stave, I used an online calculator for free that did all the math for me. Because if there's one thing I've learned over the years, it's that I'm a colors and shapes kind of guy, and I don't do math real good. So I took all the different 2x4s I bought, and I cut them into shorter sections that would be more manageable on the jointer and planer. And this process of jointing the faces flat on the jointer, sending them through the thickness planer to get them to a very specific thickness, and then doing ripping passes on the table saw is the process I learned early on in my woodworking. And while it does require investing in a jointer and planer, this opened up so many paid projects that I could say yes to and then deliver flat and stable work pieces that were worth more, which meant I could make more money and then reinvest it into my hobby and buy more equipment. This process of learning how to joint, plane, and rip changed everything for me when I was just starting out. Now, once everything was milled up, I laid all 4 lumber options side by side, and the results were not what I expected. The whitewood had some really tight grain, but it had a lot of knots, and I wasn't crazy about the look. Now, I've built a lot of stuff with white wood, and I've never liked the look. This is the look I always get, and I hate it. The Douglas fir looked pretty good, but I expected it to be better, and I was a little disappointed. And the straight southern yellow pine 2x4 looked exactly how I expected. But somehow, the reject board, the cowboy mic board, looked better than the other three. It's crazy that the worst board at Home Depot that I didn't even want to buy ended up being the best one thanks to cutting the bow out and milling it up, and that's just kind of how the grain worked. I was wrong about the 2x4s. Which one did you pick? Okay, time to cut the angles for the staves at the table saw. My friend Izzy Swan sent me one of these new expandable push sticks that he invented and now Bow Products manufactures. And if you know Izzy, you know he's one of those people whose brain just works differently. And I don't want to say that I'm jealous of him, but I am amazed at his specific strengths and how smart he is because my brain doesn't work like his. It's got this really cool, grippy anti-slip surface on the bottom, and I like that it keeps your hand quite a bit higher above the blade than most of the homemade push sticks that I've used over the years, and it expands and contracts. I honestly have never really liked the popular yellow ones that everyone uses, but I really like this one, and this one's going to be my new daily driver. So congrats to my friend Izzy on another really clever idea, and if you're looking for a good push stick to help keep all 10 fingers attached to your body, I think you'll like this one. I'll put a link to the one that I have down in the box below the like button. You're probably watching this thinking, hang on, this is a Whitworks video. Where's the epic mistake? Well, I'm glad you asked. When it came time to glue and clamp the staves, I did the obligatory dry fit, and it did not look good. In fact, it looked so bad that I had to text my friend Steve for moral support because I was convinced I had screwed up the math somewhere. After double checking everything, the numbers actually looked pretty close. Not perfect, just slightly off. Definitely some Drew level tolerances in there. But Steve thought if I just clamped it together, it'd probably pull itself into alignment and I should just send it. So I threw caution to the wind, glued it up, tightened the clamps, and I got some bad news for me, good news for your entertainment. This is my first stave shell, in case you didn't know, and it totally shows. I still don't know exactly where I went wrong. The table saw was dialed in, the fence was calibrated, and I checked everything multiple times with calipers. My best guess is it's a combination of it being soft pine, not using a feather board, which I should have, and me not feeding every stave through the saw exactly the same way, especially on that second angle cut where there's barely any material touching the fence. Later, I was talking to one of my woodworking friends who's amazing, Keith Johnson, about it. And he said that this is actually pretty common with stave construction. If you're off even by 1,000th of an inch, those errors compound around the circle, and eventually you end up with this. Now, the good news is that these gaps ended up on the inside of the shell instead of the outside. So, in an effort to be an official good YouTuber, I mixed up some Total Boat high performance epoxy, and I filled the gaps from the inside out. Now, was I worried about this? Not really. I intentionally made the staves extra thick, and my guess was that once I smoothed out the inside of the shell, most of those gaps would disappear anyway. And even if they didn't, it's on the inside. No one's ever going to see it. Now, while that cures, it's time to build some jigs. And I just want you to know that there's a Will Smith popular song joke hanging around right here, but I'm not going to swing at it, and I hope you recognize the restraint. Na 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 na. Sorry. Now, there are three things I love: building jigs out of scraps, working with woodworkers who are smarter than me, and using technology in my woodworking, which makes a lot of people mad, but I am who I am. Now, at this point, the shell was glued up, but there was still a problem. If you look closely, the inside and outside surfaces aren't smooth. All those individual staves leave little facets and ridges where they meet. And before this project, I had no idea how drum builders got rid of those. Turns out, a lot of them use routers. So my design partner, Steve, came up with two brilliantly simple jigs to tackle this problem. Now, what's especially cool is that Steve designed these jigs from over 1,500 miles away using an online program called Shaper Studio. And then he just shares the files with me, and I cut them out on my Shaper Origin. And I think this is a great example of the kind of project that something like Origin is perfect for. It's nothing huge. It's just a very specific problem that needs a very specific solution with really specific tolerances. So this jig that Steve designed uses a press fit bearing that allows the drum shell to rotate perfectly over a router bit. And because the Shaper Origin can cut so accurately, I was able to sneak up on the fit so closely that I just pushed the bearing in without any glue, and the friction was so tight it held it there. Really satisfying to get tolerances that spot on, even for a hack like me. Now this piece mounts to the shell, and the shell rides on an 8mm rod that spins inside these bearings. That assembly rides between a second jig that guides everything left and right while the drum rotates. So in theory, the shell spins, the cutter removes a tiny amount of material with each pass, and eventually everything becomes perfectly smooth. The only problem is that at this point, all of this existed primarily in Steve's head, and he didn't make this, and neither of us knew if it was going to actually work. So naturally, I turned on the router. Now the first pass was a little terrifying, not because anything was going wrong, but because it was working. The shell spun, the router cut, and there was no going back. Every pass removed just a little material, and every pass made the shell thinner. Every pass got me one step closer to either a drum or a very expensive piece of firewood. Well, not so much expensive in money, but just in my time. Now at first, it didn't look like much, just noise and sawdust and tiny shavings piling up around the jig. But after several passes, i.e. 60 minutes, something started happening. The facets from the staves began to disappear, the hard edges softened, the shell started looking less like a barrel and more like a drum. And I know that probably sounds obvious, but this is one of those moments where the project suddenly changes. Up until now, I've been looking at a bunch of individual pieces glued together, and now I'm looking at a shell, an actual drum shell. Now, because I was taking such light passes and trying very hard not to launch this thing into orbit, the process took over an hour, slowly rotating the shell, taking another pass, checking my progress, and repeating that process over and over again. Now, the other thing I couldn't stop thinking about were the gaps from my glue ups. If you've been yelling at your screen about them for the last 10 minutes, trust me, I've been thinking about them too. And the good news is that as the shell became rounder, most of them disappeared completely. The ones that weren't were buried deep inside, and they're not going to be seen anyways, which is a huge relief because by this point, I was fully committed. There's no backup plan, no second shell. This one has to work. The only problem was that I just finished the outside, and the inside still looked like a stop sign. So off camera, I built another jig. And by built, I mean I stared at the shell for a while, dug through my scrap pile, grabbed some 1-inch aluminum angle, ordered some rollers from Jeffrey Bezos, and then just started making stuff up. The idea was simple. The shell would ride on these rollers while my trim router and the whip plate rode on the aluminum rails just above it. I'd slowly rotate the shell underneath and let the router knock down the high spots on the inside. At least that was a theory. The reality was, I've seen a lot of people do this on YouTube. I just had never done it, and I fully expected a catastrophe. There's no plans, there's no copying from a forum, just me and some scraps and some fingers crossed. This is the point where I'm supposed to make up a bunch of drama, but it worked fine, really well. I was actually kind of surprised. Each pass smoothed out a little on the inside, a little more. The remaining facets disappeared, and the shell became rounder, cleaner, and it looks a lot like a drum. And for the first time in the entire project, I started to think this might actually work. A few weeks ago, I upgraded my saw stop with Harvey's Big Eye fence system and added their new Intelligent Position Manager. And the installation was surprisingly pretty simple. It's basically a camera that bolts onto the front of the fence, takes a few minutes to calibrate, and then you're off and running. Now, if you've used a table saw for any length of time, you know this game. You unlock the fence, you slide it close, then you play the tap, tap, taparoo game, lock it down, check the measurement, miss it, unlock it again, tap it again. We've all done it. What's cool about the position manager is that if you enter the exact measurement you want, you can slide the fence into position, and when you hit your mark, the display turns green and gives you an audible beep. My favorite thing about the Big Eye fence itself is how solid it is. The locking lever moves forward instead of sticking out into your hip every time you walk by, and the fence locks on both the front and rear rails. So once it's locked down, it stays put. The other nice thing is that it's universal and fits most major table saws. I'll have links in the description below if you want to check out the fence and the position manager, and special thanks to Harvey for helping me make this project possible. Now with the shelf finally round, there was one other thing to tackle. The top and the bottom weren't parallel. There were slight differences. So before I could cut what's called the bearing edge, I needed to make both ends perfectly parallel and trim the shell to its final depth. My first thought was pretty simple. I just run it through the bandsaw. Then I had a second thought. This feels like a terrible idea. So before I did anything stupid, I called my friend Alex Snodgrass, and I'm glad I did, because Alex immediately confirmed that feeding a giant wooden ring into a bandsaw blade freehand was in fact a terrible idea. So instead, he sent me a quick video showing me how to build a simple sled that supports the shell and keeps it square to the blade throughout the cut, a couple of scraps of plywood, a fence, and 20 minutes later, I had a much safer plan, but it was still pretty scary. I started by trimming one side flat, fully expecting this to go sideways, but it worked out. And then I just flipped the shell over and cut its final depth to 6.5 inches. The whole process was surprisingly eventful, which was nice because not everything that happened next was. With both ends parallel, it was finally time to cut the bearing edge. Now, if you're not a drum nerd, which is probably most of you, the bearing edge is the profile cut around the top and bottom of the shell where the drum head actually contacts the drum. There's endless debate about which profiles sound best, but everyone agrees on one thing. It matters a lot. This tiny little detail affects how the drum tunes, resonates, and ultimately sounds. So, no pressure. Now for this part, I threw my trim router into my DIY router table and the only chamfer bit that I had, and I started cutting the profile around the edge. And everything seemed to be going great. The cuts were really clean, the shell looking more and more like an actual drum. And then I stopped and looked at what I'd done, and I made a big mistake here. The point of the bearing edge was landing almost in the middle of the shell, which is not where you want the bearing edge to be at all. Turns out when you make a shell this thick, you also need a much larger chamfer bit than the one I owned. And that's the sort of detail that's really helpful knowing before you make the cut. The good news is I caught it before going too deep. The bad news is I didn't have the right bit to fix it. So while I waited for a larger chamfer bit to arrive, I shifted gears and started drilling holes for the hardware, which explains why the shell seems to magically jump ahead in a few of these shots coming up. A few days later, the new bit finally showed up and I was able to recut the bearing edges the right way, which should have been done the first time. A little bit out of order, but we got it done. Now, to rewind just a bit, I got a hardware kit off of eBay that my friend Craig from Bourbon Moth told me about. And this hardware kit, $300, turns the shell into an instrument. Now, the problem I ran into here is that every single lug had to be positioned perfectly, and there were 10 of them. And given my propensity for making errors, I was a little nervous. If I miss by even a little, the drum starts looking like it was assembled by a guy making his first drum on YouTube, which technically it was. Fortunately, my good friend Steve, who's a wonderful designer, came to the rescue. He designed a very simple spacing jig that I could 3D print to help me mark all of my pilot holes. And I know some people go crazy about using 3D printing or woodworking. This is my favorite use for a 3D printer in my workshop, is making little jigs just like this. Now, once I had all the locations marked, I drilled the pilot holes and started test fitting the hardware. And once again, it kind of looks like a drum and I'm really excited. One thing that really helped me here a lot was the match fit dovetail end vise that I made on my workbench. This is really, really easy to make and really, really cheap. Being able to clamp the shell vertically made this way easier to work, drill, and install the hardware without the shell constantly rolling away. If you want to build a vise like one of these, I covered the entire build in a previous video, and of course, plans are available. With the hardware holes drilled, it was finally time to decide how this thing was going to look. Now, I had 3 ideas. Option 1 was to clear coat it and leave it looking like it exactly was. Be honest, it's a 2x4 drum. Option 2 was my favorite. Use black India ink to dye it black, something inspired by my Mapex Black Panther. And then there was option 3, do a guitar style sunburst, which felt completely over the top, unnecessary, and was by far the hardest option. I genuinely don't like AI, and I hate when I see or read content made by a machine, not a human. However, I do like to use AI to make quick mock-ups to help me make decisions. And I know how to do this in Photoshop, but this is way faster. So I generated all 3 of these versions and I showed them to my son and I asked him which version of finish he liked. He didn't hesitate, not even for a second. He chose the sunburst immediately. Of course he wants the hardest option. But I'm not building the drum I want, I'm building the drum he wants. So I dusted off my guitar making skills, pulled out all the alcohol dyes, and I got to work. There's a great channel on YouTube called Big D Guitars. I probably watched enough of his finishing tutorials to qualify for an honorary degree. And at this point, I'm basically just copying what he does because he's pretty good at this. The process is simple in theory. Apply base color, darken the edges, blend everything, do it over and over and over again until you get something that looks like a sunburst. Then spend the next hour wondering if you've completely ruined it because you're not sure. Slowly, it comes together, and I have to admit, it turns out pretty good. Not exactly what I had in my head, but I was hoping for something closer to the sunburst I did on the Strat that I built last year. But this drum wasn't flame maple, and this was construction lumber, so I'm calling this a win. I still can't believe that this was a crooked 2x4 that I got for $1.06. At this point, the drum was starting to look pretty legit, but if I was going to fully commit to the whole custom snare thing, it needed one more detail, a proper logo badge. Not a sticker, a real metal badge. And this part ended up becoming one of my favorite parts of the whole build because it turned into a little cross-country collaboration. The first stop was Ohio. My friend David is a no-name beginner YouTuber in Ohio. His channel is called Make Something. He has almost 1 million subscribers. Very small. Pray for him. But in all seriousness, long before I ever started making videos, I was watching David, so having him help me with this felt like one of those weird full circle internet moments that didn't seem real. David had some scrap sheet metal in his shop, and so he fired up his fancy metal fab cutting machine thingy and cut a bunch of badge blanks. And then he got them ready for the next step. He boxed them up and shipped them to my friend Jeremy in New Jersey. Now, Jeremy is a subscriber and a Patreon supporter that I met last year at the Texas Woodworking Festival, and he's one of those dangerously smart people that you're glad just to have on your team. He's got a bunch of really cool lasers and printers that I don't have, and so I asked him if he could help me finish these badges because I just didn't have the machines to execute on the idea I had in my head. He used a metal laser to engrave the text, and then he used the new Eufy printer that you see all over YouTube to print the Raptor graphic on the page with extreme detail. And it was during this process that I learned that Jeremy is part of a team that reverse engineers movie robots and builds open source screen accurate CAD models for them. And while we were working on this project, there were some delays because this little company named Sony invited him and his team out for a celebration because of their work recreating, I'm not kidding, Johnny 5 from Short Circuit. Are you kidding me?
And I'm here to assist you with a variety of tasks as best I can.
So while I'm over here making a snare drum out of a Home Depot 2x4 that Cowboy Mike twisted my arm to buy, these guys are out here casually building movie robots. Eventually, when Jeremy got tired of Sony and Johnny 5, he ended up coming back and finishing the job and boxed everything up. And then we did the unthinkable. We trusted FedEx to bring it all the way back to me here in good old Fort Worth. And this is the part of the video where I have some bad news. FedEx was totally FedEx, and they lost the package. I'm kidding. They actually held up their end of the deal for once, and I had it within 2 days. So seriously, huge thanks to David and Jeremy for helping me bring this detail to life. It's a detail that my son will never forget, and I couldn't have done it without you guys. Thank you. Well, maybe not so fast. When I opened the box, I noticed the package was pretty big and really didn't know what this large thing was. And it turns out Jeremy printed a oversized coaster with Bent's Woodworking logo on it. But the joke's on you, Jeremy. You can't troll a troll. Now, these badges look super sick, and I'll explain why I went with a raptor. My son, when he was a baby, he used to scream, and it reminded me of the little baby velociraptors in the movie Jurassic Park. So I used to call him my little baby raptor. And then because his name starts with a G, I kind of turned that into my baby Graptor. And so then that turned into the nickname the Graptor Raptor, which he really doesn't like. But I think the name Graptor is the coolest nickname. So since I have a snare drum that's called the Black Panther, it totally makes sense that I would name the snare drum for my son the Graptor Raptor. Now, if you made it this far in the video, leave me a comment with the word Graptor and let me know what you think. I get a ton of comments and sometimes they're hard to filter through or respond to, but if you put the word Graptor, I'll be able to search that, see your comment, and respond to you. All right, before I give this to my son, let's do a quick test. I have both of these snares. I'm going to blank out which one is actually which. I put brand new heads identical on them. I've tried my best to tune them to be the same pitch. It's slightly off, but it's close enough. And let's see if you can figure out which snare is which. I got a nice classic sound to it. I hope you feel like you're at the optometrist. So leave in the comment which snare you think is the 2x4, A or B. All right, walk forward, forward, walk forward, walk forward, and open.
What the what?
Look at the badge.
Timmy Tough Knuckles.
What does that mean? Here's the reveal. Snare B was the Mapex. I don't know about you, but I kind of like the sound of the 2x4 snare. Totally surprised, honestly. Cowboy Mike for the win.